How to create your own programming language. That's probably a question every CS major has had at least once. You see, at the most basic level, all you need to do is build a compiler. If your compiler can understand whatever syntax you come up with and translate it into something the machine can execute, well, you have your own programming language. Of course, having a standard library, some tooling, and even a package manager would go a long way to making it actually useful in the real world. So how would you go about building your own compiler? Well, there are many approaches, but first you should know that a compiler typically consists of a front end and a back end, and sometimes even a middle end. Most people don't implement their own back ends. Instead, they target existing ones like LLVM, JVM bytecode, or even transpile to C. The reason is very simple. Backends handle all the architecture-specific details like registers, stack layouts, calling conventions, and instruction sets. That's a lot of complexity you can avoid to focus on other things. For this example, let's go with transpiling to C. That means we'll write the front end, which will output C code, then let GCC handle the rest. First, you'd build a lexer, which is just a function that scans through your source code character by character and breaks it into tokens, so numbers, keywords, identifiers, operators, and so on. It also handles whitespace and comments too. What you get is a stream of tokens that represents the structure of your code. At this point, your machine is a lot closer to making sense of the code you wrote. Next comes the parser, which is also another function, which takes those tokens and builds an abstract syntax tree, basically turning the flat sequence of tokens into a structure that represents the program's logic. You can write this by hand using recursive descent, or even generate it from a grammar specification. Once you have your abstract syntax tree, you typically need to run semantic analysis. This is where you walk the tree and verify everything makes sense. Usually you would check types, make sure variables are declared before use, and catch logical errors that are syntactically valid but semantically wrong. This is part of the program that screams at you when you use a variable out of scope. And at last, there's the code generation. You need to write another tree walker, but this time, instead of checking for errors, this one outputs C code that corresponds to each node in your tree. You write this to a .c file, run it through GCC, and you've got an executable written in your own language.